Good afternoon and welcome to this session of setting up contact in MSC Apex. This session will be a hands-on session, so in other words, a full-on demonstration. So let's immediately skip to that. So this is the model I'll use for the reference for this session. Okay, so I've split up the model into different regions already. It's pre-meshed, and there's a couple of things already in, things that's not important for the contact part. But since we're using the new interface to Nastran, so to the studies, I use the new scenarios version. There's a couple of things that's common to both constraints, loads, and so on. So I'll keep all of those together. To explain the model briefly, we've got a couple of different parts. Each of these are separate. So you've got the nuts, which is, if I zoom in there, you'll see the mesh doesn't tie up. I can hide the geometry, as you can see. So there's two separate meshes, for example. We've got washers. We've got a pipe section that's supposed to be welded into the plate. Now, a lot of these we can actually change to Boolean to geometry and then separate them again to mesh them as one single part. But since this is about contact, the intent is to keep them in place. In terms of the modeling further, we've got a couple of bolts, and we specifically use a feature called the bolts in Nastran. So what this is a apply the load to, at least initially, and then in the second load case after we apply the preload, we can lock that in place. Think of that as the first one is I'm tightening the nut until it reaches a certain load, and the second one I then lock the nut in place so that it doesn't turn further. Okay, so this I'm not going to explain in more detail. We assume you either know it or we can separately look at that. In terms of constraints, we have the locking for the preload, which we'll use in the second load case. We've got fixing the brackets. So that's at these locations in this model that I've just constrained it. And then I've got what's called constraint combinations. So I can redo this if you want, but all that this says is constraints one, let's give it a better name. I'll call this for the preload. And that one then only points to fixing the brackets, while the second one, I'm constraining both. So this is for actual load. Okay, so in this case, the second one then is a combination of the two constraints. If I hover over them, you'll also see the constraints that's going to be used for that specific one. That's for the constraints. For the loads, I only have two, a bolt preload and then some kind of a side load that we'll use for the second step. Now, again, I don't need to create these load combinations. Each of them only points to a single one in this case. But in general, if I have more than one load, we'll have to do some kind of a constraint combination, load combination. Okay, the rest is set up. I've got materials, properties, the elements, material properties are assigned to everything. I don't see it highlighted simply because I've hidden the solid. So there you can see it's applied to everything. Simple steel properties. So effectively the model is ready to get into the study except the contact bit is missing. So let's start by adding contact bodies and then the interactions and then the tables. So to do that, go to the interactions and we can do contact bodies and interactions. I'll explain them in a moment. So there are ways to automatically, if I go there, I can automatically create everything. I'm going to do the manual way simply because it's a bit more efficient in certain ways, and I'll show you what I mean by that in a moment. And in addition, even if you've used the automatic method, at the end you have to go back and debug a model if something went wrong, and that effectively looks exactly like following the manual approach. So in this case, let's start by setting up all the contact bodies itself. So I can do, let's show only that one. maybe add the plate and the pipe as well. So I'll call the first one, let's say, the bracket. And I'll pick the solid. So this one and that one. And notice in my tree this appears. Now let's switch to this mode just to keep it a bit more fixed. So there I see the bracket is applied. And then the, let's call it the plate for that center section. And the pipe section. Yes, and I can get better words or use better words for this. It's easy enough to think in terms of these. The next would be for the bolts. And the same for the washers. And then lastly, the nuts. Okay, so I should have all my contact bodies now. We can check with the bracket, the pipe, sorry, the plate and the pipe, the bolts, washers, and the nuts. Okay. So the difference, if I use the automatic method would typically create a separate contact body for each of my washers. And that would be really painful if you then had to manually set up your interactions. Yes, it sets up the interactions as well, but now we'll end up with a lot of different interactions instead of in this, since it's a relatively small number of contact bodies, it's a lot easier to do the interactions, also easier to debug. So I go back to the interactions and I set it to interactions in this case. Now I specify, and the way I typically use it is I'll specify from what and to what. So I'll specify argument's sake, this is for the bolts to the nuts. I can use the word to or whatever as well. And then I have to pick the type. Now I don't want to use the automatic method. I want to manually do it. So I want to include. The automatic settings for the moment are okay. What I plan to do is set up the interactions and then we'll go back and edit them to show you all the different settings. Ideally, we'll do this and do everything at the same time. In this case, we just want to check that everything is there. So it's the bolts to the nuts. So I'll select the bolts, middle click, and the nuts. Okay, now if I switch this off, let's see that interaction. That's what it looks like. So the idea would be this nut is glued onto the bolt because it's effectively tightened there. We don't use a method specifically to preload it based on this. We use a separate bolt modeling method that I've explained before. Okay, so then we do the second glue will be between these two parts. And again, ideally, we can join them using a Boolean operation. But again, we want to show how all of this works. So this will be, let's say, the plate to the pipe. And again, glued, the other settings stay the same for the moment. So the plate and the pipe. And ideally, I want to do this to check that it has actually done it correctly. Because I'm going to keep it in this mode temporarily. So all of the others will be touching contact. So if I switch to the next one, it will be, let's say, the bolts to the washers. The washers, now it is a contact, and then I actually need to specify some additional stuff to get correct contact. I'm going to leave it out and get back to this in a moment. Okay, so again, in this case, it's the bolts to the washers. And interestingly enough, if I plot this, it doesn't show it correctly. So let's edit this one and get it correct. So I'll specify a tolerance of 0.1. 0.1 millimeter should be good enough, and then it picks up that contact correctly. But that's not the only thing we need to change. Ideally, I need to specify the friction coefficient. And in this case, also, it's usually a good idea to activate stress-free for things that start in contact. Otherwise, if there's a slight overlap, you end up with strange results. Okay. So that's now set up for this pair. Now, again, we can do the same for the rest. So the nuts to the washers. See, I mistyped washer there. Nuts to washers. And we can now fill this in 0.1, 0.3, and activate that stress-free initial. And then this is the nuts, the washers. And if I have a look at those, they now look correct at least. So that's the nut side and that's the bolt side. Then the last two will be between the washers and the plate. So washers and the brackets, and then the brackets and the plate. So washers to plate. Notice the settings are still there, which is the advantage of doing it while you're setting it up instead of editing it afterwards. Now this is between the washers and the plate. And then lastly, between the plate, oh, sorry, that shouldn't have been the plate. Let me just double check. Shouldn't be the plate, it should be washers and the bracket. Fix it there as well. So that is picked up correctly. And then the last one will be between the plates and the bracket. So plate, bracket. Settings, just double check, then the same settings applies. And it will be between the plate and the bracket. Okay, now this one, let's just fix the terrible spelling there. Okay, so we can now have a look at everything and see that it makes sense. There's something picked up, there's something, that is the new ones, additional ones, and then lastly should be that all plate. Okay, so in this case, everything looks like all the contact at least has been defined. Now, again, once you go through all of these interactions, it's always good to, after the fact, go check all of them to see what all of the settings were. Now, we've done it in this case while we were editing it, but especially if you just create it, it's then easy to then afterwards go and check that it's set correctly and so on. Now, one thing that kind of, we didn't actually look at it, but something we have to think of is at this interface there, I'm using first order shell element, solid elements. So let's hide the solids. So these are straight lines, and well, all of them, there's a bit of interference. So yes, the stress-free will take care of that, but there will be a gap then still. So that's a bad way of doing things. Now, I will keep it like this to show you what the effect on the results would be, but to fix that is actually pretty easy. And it's another something kind of important for contact. You know, that has to do with analytical settings. So what analytical contact, if I open arguments like the plate, it's set by default to discrete. If I change this to analytical, instead of making contact on the element faces, it fits a spline through the faces. So along that edge, it will be a smooth shape. So I can do that for that one. And then I go through the list. So the plate needs to be, because there's a curved interface. Just I'm going to change it to something that okay, so at that interface there, it's a curved section, so both of these need to be curved or analytical. So that's the plate. The pipe has to be. The rest of the settings there we can talk about in a separate time. We actually have talked about it in detail in this previous session that we had on contact specifically. Okay, then for the bolts, between the bolts and the nut, we have to have that. So the bolts, that has to be analytical, and the nuts should also be analytical. Now the question is, should the washers be? That in this case actually not, but in some models it will need to be. And the reason is there's a nice large gap between them Just hide the interactions. See, there's a nice gap. So there's no interference fit. There shouldn't be interference fit at the end either. So nothing stops you from changing it. It's not supposed to make a difference in this analysis though. Okay, so at this point, we've got loads, boundary conditions, materials, properties, everything except we haven't yet specified which contacts to use together. In this case, I want all of them, obviously. So again, I need to specify a contact table. So for the loads constraints will be load combination, constraint combination. So my contact, and I select everything. Okay, the reason we want to use this, sometimes contact changes during an analysis, something is touching and later changed to glue or whatever the case would be, then we can use more than one contact table. In this case, we just leave it as is. Okay, so at this point, the model is set up. It should be ready to work. Now we need to specify my study. So I'll create a scenario of SOL 400, sorry, on top down, and only one load case. Now this is something that you have to be aware of for Nastran. For Nastran and SOL 400 specifically, load case work different to what you're used to in SOL 101, linear statics, dynamics, all of those. So in this case, every load case acts as a separate analysis. If I create this, you'll see there's one load case. If I right click on this, I can then add a step. Or in this case, I will need more than one step. So what this would be, treat that as one analysis, and then I have a preload load case and an actual load case. So let's define those quickly. We've got the preload, or more accurately, bolt preload, if it's more convenient. And then the second one would be the actual load. Okay, and then whenever you create it like this, the first thing is always to double check your model representation. Depending on the version, it may automatically fill it in or not. So in this case, I want to run everything. So that model start, which is the one that's selected, is fine. I don't need to change that. We don't need to mess with model configurations. This stuff is new features in Nastran, so it's not something that's important for this analysis. Then we need to create the loads and boundary conditions. So I've had a question a couple of times about these supports. They're very specific for very specific types of analysis. If you don't already know what it is, you probably don't need it. So this is, we want to apply constraints. Now, this is the second one that's a bit confusing, is why can I define it on different levels? And that has to do with the way that Nastran thinks and acts. So in your Nastran input file, there will be a load case for that one. And under that, there will be a step 1 and a step 2. And the way that Nastran works is if I'm on this level, in other words, before the first load case activates something like a constraint, it'll be active in anything unless it overrides it. So if you want to be certain, don't specify anything, rather specify it on this level, and I can say constraints. So that's that first one. I've got to change the name. So that's the initial constraint I want to apply. I could also have just said fix the brackets because the bolt preload shouldn't need to be fixed in this one. But let's pretend we've got a model with lots more boundary conditions and loads and stuff. So that's for the first one. And then for the, I want to constrain everything. Okay, so at this point, it's convenient because I've specified when I created the combination, called it constraints for actual load. If I click there, it'll show me which loads are actually active, which constraints are active. So it's usually easier when you set up your model to pick a name there and your combinations so that when you get here, you don't have to think about which constraint should be active and so on. At this point, we're not thinking in terms of model mode, we're thinking in terms of load cases. So it's easier to set it up like this. Okay, so then the next one is for both of these, I also have to activate a load. So for the first one, it's just that preload load that I have to apply. And for the second one, my load will be the actual load. So in the second one, I don't have the preload load on. So in other words, I'll have in the first load case only the bolt preload active. In the second, that preload is removed, but the bolts are effectively locked. So the nuts are locked, they can't turn anymore. And I'm applying this load. So that's it in terms of loads and boundary conditions. Nothing special there. I want to get back to contact because that's what the session is about. Let's fill in the rest of the things that's pretty general in terms of Nastran things that you need to set up, especially for SOL 400. Now, the same occurs for SOL 101, in other words, linear static. If you do a contact analysis, there's one or two settings that's also new there that you don't usually do. Okay, so the first one is in output control specifically. So this is not the results you're requesting. There's an echo section there, and by default, it echoes your full Nastran model into your FO6 file. I prefer using the FO6 as a debugging file, so then if I switch it off, that file becomes a lot smaller. Otherwise, you may end up with a really large file, always a pain to then debug. So that's the only change I'll consider making there. In the output requests, since it's contact, I want to activate it. Now, notice when I activate it, these settings are pretty much, if you manually enter this code in the Nastran input file, this is the default settings as well. So that's why plot is not active. If you activate plot, go back to one of these, you'll see plot is activated there. Plot means only write results to the results file, the HTF5 file. If I want to write it to the FO6 as well, I can activate this. In most cases, if you don't have anything activated, it will do both of those. So I don't want it written there. I don't want results there. I want to see error messages and so on in the FO6 file. Okay, so at this point, the model is then very close to ready to run. The only thing missing still is your, well, no, there's actually one more thing. Simulation settings. One thing we forgot to add, and that's important for contact, is we need to have load step. Now, again, I can do it on different levels, but we need to activate the NL step feature or command inside of Nastran. So to do that, I'll create a new one. My stepping or whatever I want to call it. And the advantage of using the smart method is Nastran has a built-in couple of commands that kind of automatically, based on how you think of your model, try and solve it. So the default would then be quasi-linear. So what this would do is in the background set up things like try and do the whole load increment in one step instead of breaking it down into smaller steps. There's also mildly nonlinear or severely nonlinear. Now this model is, apart from contact, pretty linear. So we don't need to bother with using smaller step size and multiple steps and so on. So that default is fine. We can also go through these and change specific settings. The most important one will probably be on that one, where you can specify which kinds of convergence criteria you want to use and tolerances and methods and so on. I'm going to leave that off and just use the defaults for now. The important bit is we need a nonlinear stepping method. Okay, so when I specify apply, you'll see that it's now listed there as active for that specific case. I go to the second one and I'll step and I activate the same. Okay, nothing changed. The second load is also pretty close to linear, other than possibly contact and friction, so I'm more than happy with these. So let's just double check the settings. So that's set to that nonlinear stepping, and this should be the same. Okay. So just remember to press apply or OK if you change something. Otherwise, you cancel before you have, then you have to redo it. Okay, now for the important bit. So this is, again, everything to do with contact. So the first and most important bit is the first option, you expand and choose what kind of contact, node to segment, segment to segment. The default is node to segment. In this model, I just ran it with segment to segment, but again, it's up to you, and we can have long discussions about which one is best for which kind of case. Second important one here is the general properties. That's a scary one. Default friction says no friction. So there's no friction model. So even if you have a friction coefficient, it does not solve friction. So you have to specify what friction model. So you can choose between these two for the segment to segment method. There's slightly more for node to segment. I'll just stick with the first one. So bilinear Coulomb method. And again, we've covered that in the contact sessions. what the different ones means. Now, in this case, this is on the scenario level because this setting is valid for everything. If I go there, you'll see there's less options that I can change over there. So that's the first bit. In other words, we have to pick which method, node to segment, segment to segment. There's some intermediate methods as well, and the friction, if you have friction. The second one is what contact models or contact tables to use. And the default is, again, no contact, which is again worrying. Now I can specify my contact table on this level. So I can specify select contact pairs or bodies, or tables rather. All body, and yeah, some of these are a bit dangerous because they may override your interaction settings. So the alternative is to specify it on this level. It doesn't matter which one you pick in this specific model. In some other models, if I have multiple load cases and different contact tables, it may make a difference. So I'll just specify it on this level and say, I want to select contact pairs or tables. So I go there and there's my contact table. Now, one thing to notice, what sometimes happens, I've already added and again removed contact pairs. So my ID for the contact pair doesn't start at 1, it starts at 9 in this case. When you create a contact table, it defaults to 1. So if they're the same, it'll highlight this and say, number 1 is both a contact table and a contact interaction. So in those cases, I'd rather, so that you know exactly what is going to be used, change the ID of the one or the other to ensure that you're using what you think you're using. Okay, so I'm happy with that contact table, and again, use the same one for the second one. Okay, so at this point, we're ready to run. So I go right-click, export. I prefer running it externally, but you may differ and just want to right-click and run simulation. Okay, so I'm not going to run it at this point. I have already ran these. The problem is it runs a while. It may take 10 minutes for the one model and 5 or so for the other one. So what I'll rather do is I'll switch to the 2 variations. Now, you may be confused about 2 variations. The one is where I, in brackets, forgot to make these analytical bodies. And the second one where I did it correctly. So this one is, I've said it with the name analytic. So analytical contact, and I've already attached the results. And what you'll see is there's 3 steps. The first one is the model right at the beginning. So before anything is applied, that's that initial stress-free and all of those settings are being applied at that step. So I then go to the one after this one, argument's sake. And at this point, it's just too sensitive. Okay. So at this point, you see the stresses are kind of reasonable, 300 MPa and so on. Now, just to show one thing in this model, if I look at the bolts, the load I've applied is supposed to generate an average stress across the shank of about 200 MPa. And if I look at that color there, it matches with the 200 MPa setting. So that the preload at that point is effectively then correct. Okay, and the stress level, the range is pretty reasonable as well. Okay, so maximum von Bezier stress 270 MPa. It's kind of expected to see higher stresses in at least some spots, obviously on the nuts and the bolts and so on. But this is just a preload. If I then go to the next step, I'll see as expected this has been down. And notice that in Apex by default, if you've got SOL 400 runs, it switches to true scaling because that's the actual deformation. It's seldom a good idea to do relative, especially for contact, but since everything here started in contact, it may make okay sense to plot what this looks like. So there you can see that part has been down a bit. Button, sorry. So there you can see it's been down a little bit. If I plot it back to true scale, you can still see it's bent a little bit, but not crazy. Okay, so that's important for nonlinear analysis, is to look at the loads in true scale for starters at least. Okay, but then the rest kind of makes sense. We expect to see higher stresses there than there. So in principle, the answer at least makes it. Now I change to the one where I forgot to make them analytical. So that's the only difference between these two models. And now I have my stresses for this one. And I see something really strange. It's really high stresses there. If I look at the numbers, it's 2.5 gigapascals. And I can just expand this a bit to see better. Hide everything and just plot the bolts. And again, we see pretty crazy stresses there. And that's simply because of these, some spots overlap and some not and so on. So you end up with really strange results in that location. Now, the way that I've recognized it immediately on seeing this is if you see these kinds of spikes, but you expect it to be smooth, that's even worse. There's a high stress and then almost zero stress in that location. Okay, so that means, and if you zoom in, you'll see, oh, there's overlap, high stress, and there's a bit of a gap, depends on which direction I checked, so it kind of makes sense. If I plot the same with analytical, that's more what I expect to see. Okay, now again, there's these little spikes there, but that's most likely due to the way that I've meshed. It's relatively coarse washers and so on, argument's sake. Okay, so that then effectively concludes the session on contact. I've covered the parts that I wanted to cover. Are there any questions or comments?
Sorry, Gert, does that mean setting it to analytical is usually the more conservative approach?
No, it's the more correct approach.
Okay.
So this would have been a lot less of an issue if I've used second order elements. For first order, you've got that straight edged approximation of a continuously curved surface. Well, if you use second order, that second order has a parabolic shape distribution, meaning you're closer to the actual rounded section. So in that case, you would have had less issues. But on the other hand, the first order excess arguments, like in this case, really efficient elements, so you want to use them if you can, but you now run into this kind of an issue. So the purpose of the analytical is to fit the spline, the smooth surface, through those edges of the first order mesh. So you're back to very close to a perfectly circular section again.
All right, thanks.
Any other questions? Okay, if there's no further questions, I just want to remind you to register for the 2 upcoming workshops. My previous session was on post-processing in Pattern. This one, obviously, the contact in Apex. So what we plan to do is for the next 2 sessions will be a practical session, which will be, you can log in, I'll send you a model that you need to set up, and in the first case, post-process to get certain results. In the second one, a small Apex model that you have to set up and get contact working and so on. So that'll be a practical session where you have to do it. Apologies. And then I'll be available to help and check and test to see if there's any problems that need to be resolved. Yeah. Okay, so if there's no further questions, then thank you for attending.